The most surprising thing about crows so far has been their ability to recognize and remember particular people, and even just particular faces.
You probably think you have privacy when you step outside your house, that no one is really watching. But right now, as you walk down the street, sit in traffic, or unlock your front door, something is tracking your face, remembering your behavior, and quietly sharing that information with others just like it. It isn't your phone. It isn't a camera. It's sitting on a power line above your head, staring back at you with black glass eyes. Crows live wherever humans live. Cities, suburbs, highways, parks. If you're there, they're there too. For centuries, we've dismissed them as noisy scavengers, background creatures. But recently, scientists tried listening to them in a new way. They fed thousands of hours of crow calls into an advanced artificial intelligence, expecting chaos, random screeches, animal noise. What they got instead made the researchers stop talking and just stare at the data. Because the AI didn't hear noise. It heard structure, patterns, rules, something uncomfortably close to language. And once the machine started sorting those sounds, it became clear the crows weren't just communicating with. The original goal of the experiment was almost boring. Researchers wanted to know if a machine could do what humans already do by ear: separate crow noises into simple categories. One sound for food, one for danger, one for a predator in the sky. It was supposed to be a basic sorting task, the kind you give an AI before moving on to anything serious. But almost immediately, the data started behaving strangely. Instead of clean, predictable groupings, the system began flagging patterns that didn't belong in any simple box. The output graphs spiked in places they shouldn't have. The AI kept linking sounds that, to human listeners, didn't seem related at all. The researchers assumed it was a glitch. They reran the model. Same result. What the machine was picking up wasn't volume or emotion. It was timing, spacing, the precise relationship between pitch and pause. When those elements were rearranged, the meaning changed completely. To us, it all sounded like the same harsh caw. To the AI, some sequences were valid and others were nonsense. That's when an uncomfortable comparison emerged. In human speech, syntax is what separates information from gibberish. The cat sat on the mat makes sense. Scramble the order and the meaning collapses. The AI was detecting that same kind of rule system inside crow calls. For generations, we've assumed animal sounds were just emotional reflexes. A bark meant excitement, a screech meant fear. But this wasn't raw emotion. This was structure layered on top of sound. The machine wasn't hearing feelings, it was reading rules. And that raised a question no one was prepared to answer yet. If crows were using something like grammar, what exactly? The first real crack in the mystery came from a sound the AI refused to ignore. Buried in the recordings was a specific sequence, subtle changes in pitch, rhythm, and spacing that appeared rarely but consistently. To a human ear, it was nothing special, just another sharp crow call lost in the noise. But the machine tagged it as unique. The researchers went back to the footage synced with the audio. In one clip, a man wearing a red hat walked through a public park. As he passed under a tree, a crow called out. The AI marked the sound. 3 days later, the same man returned. Same path, same tree. The same call appeared again. At first, it didn't seem remarkable. Animals recognized familiar shapes all the time. But then the data took a turn no one expected. A week later, the man walked through a different part of the park. A different crow, one with no prior exposure to him, made the exact same sounds. Every frequency matched. Every pause lined up. That's when the implication hit. The first crow hadn't just reacted. It had transmitted information. Not a warning, not an emotion, a description. The AI confirmed the sequence was never used for anyone else. Not similar clothing, not similar height, just him. In linguistic terms, it functioned like a proper noun, a label, a name. And once the researchers understood that, the discovery stopped feeling impressive and started feeling disturbing. Because if crows could assign identifiers to individual humans and share them across the flock, this wasn't just communication, it was documentation. They weren't just noticing people. As the analysis continued, the timeline itself started to look wrong. The AI wasn't just flagging conversations that happened when humans were present. It began detecting long, complex exchanges that occurred before any visible event took place. Groups of crows would gather in trees, vocalizing in layered sequences. Then, all settled. Minutes later, a human would enter the area. At first, researchers assumed coincidence, but the pattern kept repeating. These vocal clusters appeared again and again, detached from immediate stimuli. The AI categorized them differently, not as reactions, but as preparation, planning phases. Even more unsettling was what those conversations centered around. When the machine cross-referenced the calls with environmental data, a massive portion of crow communication wasn't about food, weather, or predators. It was about people, human movement, human objects, human behavior. The AI identified emotional markers tied to these human references. Some sequences stayed neutral, others carried sharp negative weighting. The calls for human with food were clean and calm. The calls for or human with stick or human approaching fast were tense and urgent. Same species, same setting, completely different classifications. That's when the perspective flipped. Humans weren't background noise in the crow world. We weren't random obstacles passing through their environment. We were recurring variables, important enough to monitor, discuss, and anticipate. And if they were planning around us, the next question became unavoidable. How were they even capable of thinking this far ahead? The answer sounds impossible at first, because we've been measuring intelligence the wrong way for a very long time. For over a century, scientists believed real thinking only happened in one place, the cerebral cortex. That wrinkled outer layer of the human brain became the gold standard. No cortex meant no higher thought. Birds don't have one, so the verdict was simple. Smooth brain, simple mind. But nature doesn't care about our definitions. Instead of a cortex, birds evolved something else entirely, a structure called the pallium. It doesn't look impressive. No folds, no dramatic ridges, but when researchers put it under a microscope, the illusion fell apart. The neurons inside are packed so tightly it's almost absurd. Signal paths are shorter, processing is faster. What looks primitive is actually efficient. When scientists compared brain power by weight rather than appearance, the results were shocking. A crow's brain, ounce for ounce, rivals that of a chimpanzee. That's why researchers started calling them feathered apes, not as a joke, but as a warning. This architecture explains things we once brushed off as coincidence: the memory, the planning, the ability to hold information for years. A crow's brain isn't small in function, it's compressed, like a supercomputer folded into something the size of a walnut. And once you understand that, the behaviors we're about to talk about stop sounding like animal tricks and start sounding like engineering. One of the clearest signs that something unusual was happening came from a bird most people have never heard of: the New Caledonian crow. While most animals use whatever nature gives them, these crows build what they need, not randomly, not instinctively, deliberately. In the wild, researchers watched them land on a specific plant with long, spiky leaves. The crow wouldn't tear at it blindly. It would cut into the leaf, then pull in a precise stair-step pattern, shaping a jagged edge. The result was a custom tool, perfectly designed to hook insects out of deep crevices. If the tool snapped, the crow didn't panic, it repaired it. If the right plant wasn't available, it improvised with wire or twigs. The design lived in its head before the tool ever existed. Then came the experiments that erased any remaining doubt. In one test, a treat floated inside a narrow tube of water, just out of reach. Nearby sat heavy stones and lightweight floating pieces. The crow studied both. It ignored the floating objects completely and dropped only the stones into the tube, one by one, until the water rose high enough to grab the food. No trial and error, no confusion. It understood density and displacement instantly. In another test, the food was locked inside a box with a hidden mechanism. The crow couldn't see the lever it needed to activate. It had to use a stick to push a concealed button that triggered the release. Within minutes, it solved the puzzle, not by guessing, but by forming a mental map of how the system worked. This wasn't instant. This was logic, cause and effect, multi-step problem solving. The same kind of thinking we use when we fix a machine or plan a workaround. And that's when the realization becomes uncomfortable. If a crow can analyze tools, physics, and mechanisms this precisely, intelligence is impressive. Memory is worse. And this is where the story stops being abstract and starts getting personal. Because crows don't just learn, they remember, and they don't forget. In 2006, a researcher named John Marslow at the University of Washington wanted to test whether crows could recognize individual human faces. To keep himself safe, he wore a mask, a crude caveman face, while capturing and tagging a small number of crows on campus. The birds weren't harmed, but they were furious. They screamed, thrashed, and fought the entire time. Later, Marslow walked through the same areas without the mask. Nothing happened. The crows ignored him completely. Then he tried something else. He put the caveman mask back on. The reaction was immediate. Crows dive-bombed him. They followed him across campus, screaming non-stop. To make sure it wasn't just masks in general, he wore a second one, a mask of Dick Cheney, who was vice president at the time. The crows didn't care. No reaction at all. At first, it seemed simple. The birds he captured recognized the face that threatened them. But over the following weeks, something strange happened. The number of attacking crows increased. 10 became 20. 20 became 40. Birds that had never been captured joined in. Years later, 5 years later, Marslow returned and wore the caveman mask again. Most of the original crows were gone by then. Some had died, others had moved on. And yet, the attacks continued. The new generation knew the face. That's when the conclusion became unavoidable. The crows weren't just remembering, they were teaching, describing the enemy, passing the knowledge forward. They had created a warning system that outlived the individuals who started it. The mask experiment didn't just prove recognition, it exposed scale. Because once crows can describe a a face, memory stops being individual and starts becoming collective. The AI analysis matched this perfectly. When a known human entered an area, the response wasn't delayed or localized. A call went out immediately. Nearby birds reacted before the person had even crossed the street. It wasn't a reaction chain, it was a broadcast. Crows don't just notice faces, they track behavior. If you feed them, they remember. If you threaten them, they remember that too. And they don't mix the two up. In neighborhood studies, researchers observed crows greeting one human calmly, then flying a short distance to harass another. Same day, same street, different judgment. What makes this unsettling is how far that information travels. A negative encounter doesn't stay local. Once a human is labeled, that label moves with the birds. You can annoy your crow outside your house, drive across town, and find yourself getting screamed at by birds that have never seen you before. The network moves faster than you do. Clothes don't matter. Hats don't matter. They focus on facial structure, posture, the way you move. You can change your route, but you can't change your face. And once that data's in circulation, there's no reset button. We like to think of surveillance as something humans invented. Cameras, databases, facial recognition software. But above us, something far older is doing the same thing. Facial recognition is unsettling on its own, but it's only one piece of something much bigger. Because crows don't just store information, they organize it, they judge it, and they enforce it. When a crow dies, the flock doesn't scatter. One bird discovers the body and releases a specific call. Then everything goes quiet. Other crows arrive and take positions in the surrounding trees. They don't touch the body, they don't feed, they watch for a long time. For years, scientists thought these gatherings were simple greed, but the AI analysis suggests something more calculated. During these events, low-frequency vocalizations appear that don't show up anywhere else. The patterns seem tied to what caused the death. Cat, car, human, weapon. The birds are collecting information and distributing it to the living. In other words, it's a crime scene investigation. That judgment doesn't stop with the dead. Crows have been observed enforcing social rules within their own groups. A bird that steals food from younger members or violates the hierarchy can be surrounded, screamed at, packed, and sometimes driven out entirely. Exile is a real punishment. And humans aren't exempt. The AI data shows crows can distinguish not just between people, but between intent. A human holding an umbrella triggers one response. A human holding a gun triggers another. Even posture matters. Hunters looking up into the trees are flagged differently than hikers looking down at the trail. They're not reacting to objects, but not all humans are enemies. Crows also maintain a good list, and the behaviors associated with it are just as fascinating as the punishments. People who feed them, leave scraps, or otherwise show kindness are remembered and rewarded. Shiny objects, colorful beads, small coins. These gifts have been documented in yards and gardens around the world. It's their way of paying back loyalty. The AI data supports this, showing that calls around friendly humans are softer, higher pitched, and laced with what appears to be affection. They're acknowledging value, making calculations, and trading resources for cooperation. This is an instinct. This is a cross-species economy. Food for protection, food for information, food for loyalty. Every interaction updates the database. You can't cheat it. If you give generously, the crows will remember. If you threaten them, they'll record it. Your reputation is constantly under review, and the consequences can reach far beyond your yard. By combining this judgment system with their facial recognition, communication networks, and memory, we start to see something extraordinary. Crows aren't just surviving among humans, they're creating a parallel civilization. They have laws, they have justice, and they have a history. And in that society, every human has a role: friend, enemy, or observer. And if you think that's unsettling, it only gets more complex when you realize the network doesn't stop at your street. Because the network doesn't stop local, crows are connected across cities, states, even continents. Researchers studying vocalizations noticed regional dialects. Calls in New York sound different from those in London. That made sense, but the AI revealed something far stranger. Specific calls, especially alarms or labels for food and threats, were traveling across dialects like a viral meme. A call might start in a Chicago suburb. 6 months later, the exact same sequence appeared in St. Louis, then spread outward. It wasn't migration, it was information transfer. Knowledge traveled faster than the humans who might inadvertently threaten them. A new predator, a novel trap, a human behavior. All of it could be shared with blocks hundreds of miles away before anyone saw it. It's an analog internet, real-time updates, cultural transmission. They are teaching each other without ever meeting, building on past generations' knowledge. Unlike humans who need books or networks, crows accomplish this entirely through sound and memory. Each generation doesn't start from scratch. They inherit history. A bird born this year can know what happened 10 years ago, not because it experienced it, but because its elders communicated it. And the AI shows it's remarkably detailed. And yet, just when we thought we were close to decoding the system, the crows changed the rules. A new pattern emerged emerged that the AI couldn't interpret, a shift in structure, in rhythm, in everything the machine had learned. And that's when things went truly silent. For months, the AI had been an almost perfect translator. It was quietly cataloging calls, decoding syntax, mapping relationships, even tracking gossip and warnings across flocks. It felt like humanity was finally eavesdropping on an alien intelligence. Then, suddenly, the data broke. Patterns that had been clear, predictable, and replicable vanished. A new strange rhythm appeared in the calls, a structure that had never been recorded in ornithological history. It wasn't just a regional dialect shift. The change spread through local flocks like wildfire, jumping territories in days, leaving the AI's confidence metrics in shambles. Researchers were baffled. The machine no longer translated meaning. It just recorded noise. And yet, the behavioral observations suggested intelligence behind it. Crows are known to test boundaries, teasing predators, dropping nuts in front of cars to gauge reaction times. But this time, humans weren't reacting. They weren't chasing, scaring, or interfering. They were silent observers, recording, analyzing. Some behaviorists propose a chilling theory. The crows noticed. They realized their communication was being intercepted. The AI, in effect, had become the experiment subject, and the birds responded by changing the code, adapting their language to encrypt it, hiding the true meaning beneath layers of interference. If that's true, it means the silence we now hear isn't absence. It's a secure channel. The birds have gone dark, aware that they're being watched, and are passing information in ways we haven't yet understood. And that raises a final, terrifying question. If they can hide their speech from us, what are they saying now in the shadow? That question forces the entire story to flip on its head. We like to imagine ourselves as the observers, the intelligent species quietly studying the natural world from a safe distance. But if the crows changed their behavior because they realized we were listening, then we were never in control to begin with. At that point, the glass between observer and subject shatters. The terrarium taps back. Crows have already shown they can recognize faces for years, pass information across generations, solve multi-step physics problems, enforce social rules, and adapt their communication when the environment changes, not slowly, instantly. The idea that they could notice surveillance and respond to it isn't science fiction anymore, it's pattern recognition. If their new vocalizations are encryption, then the chaotic noise the AI is recording now may be deliberate, misdirection, a layer of static meant to confuse anything listening too closely, while the real information moves through channels we don't yet know how to detect. Subtle timing shifts, body language, flight paths, or frequencies outside our equipment's range. And that leaves us in an unfamiliar position. We are no longer invisible. We are the ones being watched by something that knows we're watching back. The dynamic has changed permanently. So the next time you see a crow perched on a power line staring down at you, ask yourself a simple question. Is it just a bird, or is it a scout logging your face, your habits, your reputation, and uploading it to a network you'll never see? Because if they know we're listening, then whatever they're saying, and that's the part that should stay with you. Not the idea that crows are smart or even that they communicate in complex ways, but that they may be actively choosing what we're allowed to hear. We've spent decades building machines to watch everything around us, convinced intelligence only flows in one direction. But above our streets, on wires and rooftops, something older has been doing the same thing quietly and far more efficiently. Every step you take outside is logged in a way you'll never access. Every interaction, every gesture, every moment of kindness or aggression becomes part of a story that isn't written in books or stored on servers, but carried in living memory, passed from bird to bird. You don't need to do anything dramatic to be noticed. You already are. The unsettling truth is that nothing about this system requires malice. Crows aren't plotting in the way humans plot. They're adapting, observing, categorizing, doing exactly what intelligence does when it shares space with another unpredictable force. And right now, that force is us. We tend to think of ourselves as the only species capable of building civilizations, laws, and networks of knowledge. But maybe we're not as alone at the top as we thought. Maybe we're just late to realizing that another intelligence has been watching us all along, forming opinions, keeping records, and deciding where we fit in its world. So the next time a crow tilts its head and locks eyes with you, don't brush it off. Somewhere in that, all of this brings us to a quiet but unsettling realization. For as long as we've been studying intelligence, we've assumed it had to look like ours. Language Language meant words. Memory meant writing. Civilization meant cities and tools shaped by human hands. But crows don't need any of that. They've built something parallel, something layered directly on top of our world, hiding in plain sight. They recognize us. They remember us. They talk about us when we're not around. They share those stories across generations and across distance. And when they sense they're being watched, they adapt, not slowly, instantly. The unsettling part isn't that they're smarter than we thought. It's that they may understand us better than we understand them. They know our faces, our habits, our intentions. They know who feeds them and who threatens them. And once that judgment is made, it doesn't fade with time. So maybe the real question isn't whether crows have a language, or even whether they're hiding it from us. The real question is what it means to share a world with an intelligence that has been quietly observing us for thousands of years and never felt the need to explain itself. Because the next time you step outside and feel like you're being watched, you might be right.